Now, before we start trying to apply the material balances to solve this benzene toluene distillation problem, we actually want to take a step back first, and we want to make sure that we actually have enough information in order to solve this problem. And the way we're going to do that, the way to figure out if we have enough information, is we're going to calculate the degrees of freedom of our system. Okay? And so for all material balance problems, and eventually energy balance problems as well, after you draw your process flow diagram and identify the variables that you need to solve for, the next thing you should do is you should calculate your degrees of freedom. All right. And so you should do a degree of freedom analysis. Okay? And I'll abbreviate it as DOF. Okay? Now, you may have heard about degrees of freedom in your MEB1 class, and it's covered quite extensively in Chapter 4 of the book. Right? But I just want to take a moment to discuss it, because it is a very useful tool for helping you solve these material balance problems, or at least, helping you develop a strategy to solve your material balance problems. And so this degree of freedom analysis is an efficient way to figure out or to determine if you have enough information to solve your problem. Have enough info to solve problem. Okay. And so, by doing that, if you do determine you have enough info to solve a problem, then you could start applying material balances. But perhaps maybe even more importantly, if you determine you do not have enough information, then this prevents you from wasting time on unsolvable problems. Okay? All right, and so for any sort of homework problem, quiz problem, or exam problem that you do in this course, I'm going to highly encourage you to perform these degree of freedom analyses for any system that you encounter. So homework, quiz, and exam problems. Okay. All right, and so if we take a quick look at the textbook, you can see that chapter 4.3 of the textbook, they go over in detail about what the degree of freedom analysis is, and then how to actually apply it. Right? And so depending on the type of material balance that you're going to use, the steps are going to change slightly a bit for the degree of freedom analysis. But basically, I first just want to introduce you to, how you do it for a molecular species balance, which is what we're going to use to solve our distillation problem. All right? And so for these types of material balance, you could calculate your degrees of freedom by identifying the following pieces of information. Okay? So the first thing you want to do is you want to determine your number of unknown variables. Okay? Then, with that number, you then add on to it the number of independent reactions that you have. For that sum, then you subtract off the number of independent molecular species that are in your system. And then you also subtract off, any other sorts of equations that relate the variables in your system with each other. Okay? And so you add up and subtract off all those things, and in the end, you're going to get your degrees of freedom. Okay? And the key here is that if your degrees of freedom is equal to 0, then you could solve your problem. If your degrees of freedom is greater than 0, that means you can't solve your problem and you need more info. And if your degrees of freedom are less than 0, then your system is overdefined. And really that means just something is wrong with the setup of the problem. Okay? Alright, so in the following video, we're going to get some practice, calculating and applying the degree of freedom analysis.